6.3, graphs of the sine and cosine functions. Many things in daily life repeat with a predictable pattern, such as weather, tides, and hours of daylight. So this predictable pattern, check it out. Here is a graph of the average temperatures of Little Rock, Arkansas. And so you can see the January temperature is low, and then it goes up, and the highest temperatures are in July, August somewhere, and then it goes back down in December. You would expect this to keep repeating over and over and over again. So how often does it repeat? Well, this particular graph, it's going to repeat something like this curve every 12 months. So when they talk about a predictable pattern, in that case, it'd be like every 12 months. So it repeats itself every 12 months. We've got this unit circle, and I don't have anything filled in yet, but the circumference of the unit circle is 2 pi. So think about a radius of 1. If you found the circumference of this, it would be 2 pi. So all the way around the circle is 2 pi. That's going to be super important. So the least possible value of p for which the sine and cosine functions repeat is 2 pi. All right, so p is that predictable pattern. All right, it's also known as the period, and that's going to be important for us to be able to find so we can draw graphs of the sine and cosine functions. Okay, now I filled in the unit circle a little bit, and or a lot, and you don't really need to fill in all of this if you don't want to. You can, of course, if you want to, but I wanted to use these numbers to help explain what this chart means. Okay, so we look at these points, and we've got square root of 3 over 2 comma 1/2, and square root of 2 over 2 comma square root of 2 over 2. If you remember those decimal abbreviations or approximations that we've talked about before, we might be looking more at numbers like 0.866 comma 0.5, and maybe that will make more sense to you when we look at this. Okay, so it says from 0 to pi over 2, sine increases from 0 to 1. So remember, the sine function, sine goes with y, right? We know this from a previous chapter. But if you look at the y coordinate, from 0 to pi over 2, the y coordinate goes from 0 to 0.5 to 0.707 to 0.866 to 1. So when it says it increases from 0 to 1, from 0 to pi over 2, the y number increases from 0 to 1, and then from pi over 2 to pi, as we go around the circle, notice what happens to the y value. There's 0.866, 0.707, 0.5, and 0. So we can see that y number decreasing. And then as we keep going around to the next 1/4 of the circle, from pi to 3 pi over 2, the y number goes from 0, negative 0.5, negative 0.7, negative 0.8, negative 1. It decreases from 0 to negative 1. And then the rest of the way around, from 3 pi over 2 to 2 pi, we're increasing from negative 1, negative 0.8, negative 0.7, negative 0.5, and back to 0. So all this says is it's talking about the y number for the sine. And then if you wanted to look at cosine, you'd have to remember that cosine is the x number. So notice the x number as we go around, it starts at 1, 0.8, 0.7, 0.5. See how it's decreasing? That's what this says. And then it's going to go from pi over 2 to pi. So the next part, it goes from 0 to negative 0.5, negative 0.7, negative 0.8, negative 1. So it's decreasing to negative 1. Now it's going to increase, negative 0.8, negative 0.7, negative 0.5 to 0, increase. And then it's going to increase again, 0.5, 0.7, 0.866, and 1. Okay, so all this chart is talking about is it's talking about how the x and y numbers behave. But really, you know, they're talking about this thing is increasing for a while, and then it's decreasing for a while. And then it'll increase for a while, decrease, and so on and so on and so on. Here we're going to graph the sine function, and I'm going to just tell you some different things about what it does and what it looks like.
So here's a graph. If I use Desmos, here's a graph. And what you should notice is that it starts at 0. And when we get to this point over here at 2 pi, x equals 2 pi, it's actually theta equals 2 pi. That's where the graph starts over. Okay, so keep that in mind. It's a sine curve, but it's going to replicate itself every 2 pi. So how I would draw this is basically what I'm going to do is I'm going to mark off 2 pi, and then I'm going to cut that in half, and I'm going to cut that in half again. I want 4 equal parts, because what those 4 equal parts are going to do is they're going to take me back to my unit circle, and they're going to represent these 4 points of my unit circle like an angle of 0. All right. If I have an angle of 0 and I look at this point 1, 0, I know sine is the y coordinate, and so sine at 0 is this 0. I know there's a dot right there. Okay. This angle right here happens to be pi over 2. And so pi over 2 is this angle up here. And this coordinate would be 0, 1. And so if I wanted to do sine pi over 2, I would look at the y coordinate, and I would know there's a dot right there at 1. As I go around, the next angle is pi, and those coordinates are -1, 0. The sine of pi is 0. This next angle is 3 pi over 2, which takes me down to here, 3 pi over 2, and that point is 0, -1. And so sine of 3 pi over 2 is -1. There's going to be a dot right there. And then I get back to 2 pi. And sine of 2 pi is 0. And so there's my graph. Okay, go back and look at Desmos. Desmos looks a lot nicer than my hand drawn, but it's still the same. It's still the same shape. The reason mine might look a little squished or a little different is just because of the scale. But it's the same thing. I just stretched mine out a little bit differently than Desmos did. All right, so that is one period of the graph. What we're going to do after that is we're just going to repeat the pattern. It looks like every 2 tick marks goes up or down 1. So there's going to be one here, and here, and here, and here, here, here. I'm not really doing any calculations. I'm just playing with the numbers and playing with the pattern. All right? So that is the graph of the sine function, y equals sine x. That's the parent function. I can stretch it and shift it and flip it and do all sorts of different things with it, but that's the parent function. That's the first one that we see. This graph is continuous over the entire domain. That means there's no holes and no asymptotes. I can trace this thing completely from left to right without picking up my pencil. The x-intercepts are like 0 and pi and 2 pi and 3 pi. They are multiples of pi, so I'm going to say in pi are my intercepts. The period is the amount of time it takes to repeat itself. And so that was the very first thing that I drew, that first curve right here. One full period took 2 pi to complete. Amplitude is, I don't want to say height, but it's basically how high it goes, okay? It's the maximum from 0 to 1. The amplitude is 1. This thing has symmetry with the origin. Remember when I talked about symmetry, I talked about odd and even. This function is odd. Okay, and what I did when I talked about that before is I said, all right, this is my body on the y-axis. And we got legs and a head. And if you imagine this being my arms right here. Here are my arms. One's up and one's down. That's odd. We talked about that. If they were both up, that would be even. If they were both down, that would be even. But if one's up and one's down, that looks like an odd function. Okay, so let me get rid of this little stick man here. All right, that's odd, and odd is going to have this weird property, sine negative x equals negative sine x. And that's we're going to have to deal with that a little bit later, okay? We'll talk more about that later. So now let's do cosine. Cosine, we pretty much do the same thing. We look at these points. And the period is still 2 pi. So we're still going to have those same 4 dots for now. Later it'll get stretched and moved and we'll do some different things, but for now that's it. So you look at your cosine numbers, and cosine of 0 is 1, so I start at 1, and cosine of pi over 2 is 0, and cosine of pi is -1, and cosine of 3 pi over 2 is 0, and cosine of 2 pi is back to 1. And so it's a little bit difficult to draw that first cosine wave, the first period of the cosine wave. People think it looks like a V shape. Don't make it pointy. Make sure you make it rounded. We can continue the pattern like this. And draw the cosine wave. Now notice the first period was just right there. That's one period of the graph. But this thing is also continuous. This one has x-intercepts at pi over 2, 3 pi over 2, 5 pi over 2. Basically, those things are odd multiples of pi over 2. We've seen that number before. 2n plus 1 is an odd number, so that just says odd multiples of pi over 2. The period is still 2 pi. The amplitude is still 1. This one has symmetry with the y-axis, though. Notice the little man or person, the arms are going down and down, down and down, makes that even. And this cosine graph has this property. Cosine negative x equals cosine x. I'm going to skip ahead and show you the steps and then come back. The slides got a little bit out of order. So these are steps for how to sketch. Step 1, you want to find the period, and for a sine and a cosine, this is only going to be good for sine and cosine. The period is 2 pi over b, and I'll show you what b is here in a second, but that's going to be important. It's 2 pi over b, and then find the amplitude a. Those numbers are pretty easy to get, and they're pretty easy to see, but you have to find those first. You're going to mark off the period on the x-axis, okay, mark off the period. And then you're going to cut that mark into 4 equal parts. So I'll say half of that and half again would cut me into 4 equal parts. So that's what you're going to want to do. Use the unit circle to evaluate the function. So really all you need are these 4 points. If you can get these 4 points, it's like a shortcut and you're not going to have to plug in and make a XY table. Step 4, extend the graph. So just, make it as long as you need. 2 periods, 3 periods, fill up the graph, whatever. Example 1 says graph y equals 2 sine x. The number in front right here gives you the amplitude. And that's going to tell you how high it is, how tall it is. It's like a multiplier. All right. The number in front of the x right here is your b number. So when you calculate the period is 2 pi over b. In this case, that's 2 pi over 1. So the period is 2 pi, okay? That's important because that tells you when to start the curve over, all right? We know what a sine curve looks like. It's going to look like this, but that 2 pi tells me where I'm going to start over, okay? So make sure you know your unit circle, at least the 4 quadrantal points. Coordinates are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. That's really, really important. Okay? So what we do is we start at an angle of 0, right? At an angle of 0, we look at the sine, so we look at the y coordinate, and so at an angle of 0, we will have a value of 0. Just think about plugging in 0, okay? So what's happening is, I guess I forgot the steps here. We found, step 1, we found the period and the amplitude, but step 2, we need to mark that period on the x-axis. So if you mark off 2 pi, that's right there. If you cut that in half and half again, that just so happens to coincide with the angles that are in my circle. That won't always happen. It might be more complicated, but in this case, that's what we've got. Okay, so the next point I want to plug in, I could plug in anything I want, but I'm trying to make it easy on myself, and I'm going to plug in pi over 2, which leads me to a value of 1. So when the angle is pi over 2, think about sine pi over 2. Sine pi over 2, you get 1. Okay? But here's where that amplitude comes in. Okay? That amplitude, really our value, is going to get multiplied by 2. So our circle value was 1, but the amplitude stretches it up to 2, or it multiplies all of the numbers by 2. Okay? If we did sine pi, we'd get 0 times the 2 is still 0. If we did sine of 3 pi over 2, we would get negative 1 times the amplitude of 2 is going to give me a negative 2. And then I get all the way back around to 2 pi, and sine 2 pi is 0 times 2 is still 0. So if you can get that far, you got this sine wave. That's 1 full period of the sine wave. Okay? That's 1 period, and now it's going to restart. But what you'll want to do is just kind of complete the pattern. So 2 dots over and 2 dots up. We're going to see that. We're going to go down 2 and up 2 and up 2 and down 2 and down 2 and up 2. I want to extend that graph, and that's the graph of 2 sine x. Now what about sine 2x? Okay, sine 2x is a little bit different. First of all, the amplitude. Okay, you find the amplitude, that's the number in the front, that's 1. That's telling you how high it's going to go. This number right here is that b number, and so you calculate the period of 2 pi over b. In this case, that's 2 pi over 2, which will reduce down to pi. So what that means is, mark off pi right there. That's how long it's going to take until this curve repeats itself. Cut that in half, and cut that in half. You've got your 4 equal parts like this. Okay. Now, you go around the circle, and there's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay? When you plug in 0, you're going to get 0. Okay? Now, the thing is, the trick is, when you plug in 0, you're really plugging in 0 times 2. Okay, so that's what's gonna do something weird. But 2 times 0 is still 0. Sine 0 is 0. Right there. Okay. Now, if you think about it, half of pi was pi over 2, and so half of that is pi over 4. So at that first red mark, we're plugging in pi over 4. Okay. I don't want to have to plug stuff in, but that's what we're doing. We're plugging in pi over 4. And so if you look at your equation, it's sine 2 times pi over 4. And what happens is 2 cancels with the 4 and gives me pi over 2. And so that takes us right back up to here at pi over 2. And so we're not taking sine of pi over 4. It's getting doubled, so it's sine pi over 2. And sine pi over 2 is 1, and that's why we're going to graph right there. Okay? I'm going to do one more, and then we're not going to plug any more in. If I plug in the next number, it's pi over 2. It's sine 2x, so sine 2 pi over 2. Again, the 2 cancels. And so this turns into sine pi, and sine pi means I can look at the y-coordinate at pi, that's back to 0. This is going to happen for all of your problems. The way that we've done this, by calculating the period and cutting it into 4 equal parts, it's always going to end up going back to your circle. Okay? So the shortcut is I don't really have to plug anything in. I'm just going to go back to my circle. All right? And it's going to toggle between 0 and 1 and 0 and negative 1 and 0 and 1. It's going to go back and forth over and over and over again. So my next number I plug in is going to be negative 1. And my next number gets me back to 0. So my sine curve looks like this. Now notice the difference between the last one. Okay? The last one had a larger period. It had a period of 2 pi, so it took a lot longer before it repeated itself. The last one always also had an amplitude of 2, so this one's a little bit different. Continue the pattern, up 1, down 1, down 1, up 1. Okay, now don't fall into the trap of making this a sharp curve. This should be a curve. I don't want to see shark teeth. I want to see curves. Example 3, we're graphing y equals cosine 2/3 x. Okay, cosine 2/3 x. This is kind of a weird one. You can see the amplitude, because it's the number in the front, is 1. The period is a little bit harder to calculate. You've got 2 pi over b, but in this case, b is a fraction 2/3. Now, I would love it if you guys would get over your fear of fractions. I'm dividing fractions, and you should know how to divide fractions, okay? Maybe you forgot, but figure it out. Remember it. I'm telling you right now, when you divide by fraction, you multiply by the reciprocal, okay? Divide fraction, multiply reciprocal. Those 2's cancel. And I end up getting 3 pi there, which is kind of a weird number, okay? I get 3 pi on that number. So fine, mark that. Okay, that is the period of the cosine wave. One full cosine wave will fit inside that 3 pi. And what you do is cut it in half. So there's going to be a tick mark right there. And then half again, there's going to be one right there. So it looks like there'll be a tick mark every 3 marks. I don't really care to label the tick marks. You can if you want to, but sometimes the fractions make it difficult. Okay, so what I'm going to do, I'm going to look at that circle again, like I always do. 1, 0, 0, 1, negative 1, 0, 0, negative 1. All right, this is a cosine graph, okay? And so if you plug in 0, you have to notice that it's 2/3 times 0, but 2/3 times 0 is still 0, so we're still looking at an angle of 0, and cosine of 0 is 1. So this graph starts at 1, and just remember, that's what the cosine does. The cosine starts at its maximum there, at 1. And so you go to your next red mark, okay? It turns out that that red mark right there is 3/4 pi. Shouldn't take you that long to think about why that's 3/4 pi if you look at the tick marks on the graph. So the equation says cosine of 2/3 times 3/4 pi once I plug that in. And if you think about it, 3's cancel, 2 goes into 4 twice. By plugging in 3/4 pi into that equation, the 2/3 changes me into pi over 2. Okay, this is the thing that makes this a shortcut, I guess. I don't really have to do very much calculations because it turned me into pi over 2, which means I'm looking at cosine pi over 2 is that number right there, 0. All right, cosine pi over 2 is 0, and so then my result here is 0. The next number, whatever that fraction is, I don't really care because it's going to turn me into pi, and I'm going to be looking at this number right here. Cosine of whatever, the cosine of 2/3 times whatever that is going to be -1. Okay? At some point, you're going to nail down the pattern, and you're going to know that the next number is here and the next number is here, and you're not even going to think about the numbers. Okay? So one full cosine wave looks like this. Other than that, just complete the pattern. I skipped one? Oh, I did, didn't I? Yeah, I messed up. Okay, check it out. Remember when I said every third mark? I didn't do that. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Thank you. That's why, like, you'll be able to tell if you mess up because it just looks, it doesn't look symmetrical. It looks asymmetrical. So, thank you. Every third mark would be a change. How's that? Does that look better? Yeah, I think that looks better. I think this problem is harder than I want it, especially since I provided graph paper. So I'm going to change this thing slightly. I'm going to change the equation to -2 sine 1/2 x. I think that'll be more enlightening for you. Okay? The negative sign is going to be a flip. So think about a normal sine curve. Normal sine curve does this. You'd flip it upside down, and so the first hump is going to go down instead of the first hump going up. Okay? This number 2 is the amplitude. You wouldn't say it's an amplitude of -2. You would say it's an amplitude of 2 with a flip. For the period, you're still going to do 2 pi over b. b is just a fraction. b is 1/2, so you have 2 pi over 1/2. When we divide fractions, we multiply by the reciprocal. 2 pi times 2 over 1 is 4 pi. Okay, so the period on this one is 4 pi. Now, we've got a problem here because my graph paper doesn't seem to be big enough for 4 pi, so just improvise, all right? We need a period of 4 pi, so just make your paper bigger. Problem solved. Okay? That's the amount of space before this sine curve is going to start repeating itself. Okay? So I mark off the period of 4 pi, cut it in half, that's 2 pi, cut it in half again, right there. I'm trying to divide into 4 equal parts. So I've got 4 equal parts now. All right? It always goes back to the circle. So you go back to that circle, and okay, this point is 1, 0, and this point is 0, 1, and this point -1, 0, and this point is 0, -1. Okay, so the way this works is whatever you plug in on these, if you plug in one of these 4 points, it's going to take you back to the circle. So we plug in an angle of 0, and since this is a sine function, we look at our y number, you get 0, and all of that stuff, you multiply it out, multiply by -2, you're still going to get 0. The next number I'm going to plug in is pi. That's the next angle I want to plug in. Okay, so what happens when you plug in a pi, it's going to say 1/2 times pi, so you're actually taking sine of pi over 2, and that's why you're going up here to this part of the circle. So sine of pi over 2 is 1, but don't forget you're going to have to multiply by this multiplier, -2. -2 times 1 is going to take me down here. That's why my sine curve is flipped. Look at the next sine number. It's going to be 0, You can multiply by -2, you're still going to get 0. The next y number is -1. You're going to have to multiply by that -2, that multiplier, and you're going to get +2. And then you're back to the start, 0. And that gets me right there. So we've got a flipped sine curve with a period of 4 pi and an amplitude of 2. Continue the pattern. Looks like it's got a dot here, and here, and here. There we go. Now, I want to show you what it would look like if you graphed this thing by hand. So -2 sine 3x. Okay, so let's say I hadn't changed it. The original problem was this, -2 sine 3x. Okay, so the period 2 pi over b for this one is 2 pi over 3. Okay, and it still has an amplitude of 2 with a flip. But here's what I would do if I was going to do it by hand without graph paper. Okay, I would do this. I would mark off the period of 2 pi over 3. Okay, and I would cut that in half. And half of 2 pi over 3 is pi over 3, and cut that in half. And I might not even label those. You don't have to label everything. Okay, and so I would still go to my circle. 1, 0, 0, 1, -1, 0, and 0, -1. And I would just go around the circle. I'm going to start at 0. And my next number is 1, times this multiplier of -2, that's going to be -2. So we would go 1, 2, 1, 2, and we go down to at that first mark. Okay? Because remember what I did, I had that period and I cut it in half and I cut it in half again. Okay? So then the next number is going to be 0. So go back to 0, and then the next number, the next y number or sine number is -1. But remember, I'm multiplying by -2, so that gets me to +2. And then I come back down to 0. So there is my first period of that graph. Okay, it's actually easier to do by hand than it was with the graph paper, just because the tick marks get so messed up. So be able to do it by hand. That's one period, and you should, we could always extend it out to more if we needed to. Let's do this one. Okay. The trick here, the thing that's different about this is if you get a multiple of pi. Okay, so right here, when you've got that multiple of pi here, sometimes that weirds people out. But we're graphing y equals -3 cosine pi x. Starts off the same. There's an amplitude of 3 with a flip. So a cosine graph kind of starts up high on its peak. If it's flipped, it's going to start in its valley. All right, but when we do the period is 2 pi over b. In this case, b is pi. And so it looks like something nice is going to happen because the pi cancels out and we get a period of 2. Okay. Thing that's weird is it's hard to see where 2 is on my graph paper. If you were doing it by hand, it'd be easy. I would just go, okay, here's 2, half of that's 1, half again, half again. That's what I would do if I was doing it by hand. Okay. But in this case, it's kind of difficult to see where 2 is. If you understand that pi is 3.14, then maybe you'd know that 2 is probably around in, what, like right here somewhere? Okay, so that's kind of tough. That's kind of tough to do. Half of that and half again. Looking at your circle, 1, 0, 0, 1, -1, 0, 0, -1. I keep going back here. I'm looking at a cosine graph, so then that means I look at my x number. Normally I would start at 1, but since I've got a multiplier of -3, I take that 1 times the -3. And that means I start down here at -3. My next x number is 0 times -3 is 0. My next x number is -1 times -3 is +3. Now I've got 0 times -3 gives me 0. Once you get on a roll here, you just see the pattern though, and you're not going to think about numbers at all. You're just going to think, I'm going up, I'm going down, I'm going up, I'm going down, that kind of thing. The next number, without even looking at anything, I know is going to go down there because that's what the pattern does. Okay? So I've got one period of this curve right here. Okay? I need to finish that. Okay, I need to draw this over one full period or all of the periods that I can, and that's what's going to be tough. Okay, I'm going to pause the video while I do that so you don't have to watch a minute of me putting in tick marks. Pause it for a second. All right, so I've got it. It doesn't look real nice because this one was really hard to do. I think most of your problems are going to be a lot easier to do than that one. Notice that this one says over one period. So technically, if you followed the directions, we wouldn't have had to draw all of those. We would have only had to draw one period of that curve. All right, so make sure you follow the directions and do however many periods you're required to draw on your graph.